Assalamu alaikum students. We are studying a course Organic Polymer, and today we will study a detailed topic and with mechanism. The topic name is chain growth polymerization or addition polymerization. In chain growth or addition polymerization, the molecule of monomers are added together to form a large chain molecule without the elimination of any byproduct molecule is called chain growth polymerization or addition polymerization. The monomers may be of the same type or different type, generally alkene, alkadiene, and their derivatives are used. The example of the chain growth polymerization includes polyethylene, polyolefins, polyvinyl chloride, and cyclic polymers. So this is a monomer n number we used, or we can say that if we take n number of monomers, and monomer is ethylene monomer, and it will polymerize to form a polyethylene, a large polymer, CS2 single bond CS2, and it comprised whole N. N is used for the repeating units or repeating numbers. In chain growth polymerization, the lengthening of chain occurs as a result of the formation of either free radical or ionic species. This is important, students. The chain growth polymerization, it proceeds either free radical mechanism or ionic mechanism or ionic species. So, initiator or catalyst generates active species that attack the monomer. It may be free radical, anions or cations included. So, the addition polymerization is also called chain growth polymerization because it proceeds through stages and produce reactive intermediates for use in the next stage during the growth of chain. It's important point, students, why we call the addition polymerization as a chain growth polymerization. The reason is it proceeds through different stages. Stages, what type of stages, students? It may be initiation stage, propagation stage, and termination stage. So, depending upon the nature of reactive intermediates which are involved during the polymerization, chain growth polymerization have two types. The naming of two types is the free radical polymerization and ionic polymerization. Students, we will discuss its first type, free radical polymerization, in today's lecture. The unsaturated compounds like alkene, alkadiene, or their derivatives undergo free radical addition polymerization in presence of radical generator or initiator. So when the condition is unsaturated compounds, means compound having a double bond. For example, it may be alkene or alkadiene or their derivatives which undergo free radical addition polymerization in the presence of radical initiator or radical generator. What does mean it's? Students, it means that we need a initiator for initiation our reaction. So what type of initiator we can use? The example is benzoyl peroxide, tertiary-butyl peroxide, etc. are generally used as initiator. So students, it's a tertiary butyl peroxide. When this oxygen Students, this oxygen bond oxygen, it is mainly peroxide. When this bond break homolytically mean in equally, it will break this bond homolytically in equal fashion, then this bond move towards their sides as a free radical in the presence of either heat or light, and it converted into a free radical. These two molecules of tertiary butyl peroxide free radical in front of you. This dot is actually showing the free radical. So total 3 steps involved in free radical polymerization. The steps are initiation, it means start, propagation, mean growth, termination, stand for end. We will discuss each step one by one. Students, before proceeding the first step initiation, we have studied that we need an initiator. So first we required initiator. If we use hydrogen peroxide and it will treat heatedly, this oxygen bond oxygen will break homolytically and it will convert into a free radical, 2OH free radical. Another example is, it is a benzoyl peroxide. This terminal side benzo group is present, C6H5COO bond O. This central O bond O is a peroxide species. So if we heat it, it will break, and homolytically this bond oxygen, it will break homolytically and it will convert into benzoyloxy radical. But actually students, this bond, carbon-carbon bond, this will further break homolytically. The reason is that this benzoyloxy radical is not stable one. This bond is break and the this carbon dioxide molecule releases from it and it will convert into the phenyl radical, and this phenyl radical is stable one and active one and used for the initiation purposes as a initiator. So chain initiation, this is the first step of polymerization. Students, we have already studied it. The first step is initiation. So we will discuss in detail here. Chain initiation. This is the first step of polymerization reaction where initiator molecule decomposes in mild condition to give free radicals, as we have already seen in above topic, which act as an initiator for polymerization and activate the monomeric unit, resulting in the formation of active center in monomer units. The second step is chain propagation. This reaction occurs between already formed free radical and an inactive monomer. Students, in first step we have generated a free radical which is attack on a monomer, and now in chain propagation the earlier chain will grow in this step. So this reaction occur between already formed free radicals and an inactive monomers. Active center in monomer unit attack an other monomer molecule to form a large free radical. The radical formed adds to an other monomer molecule to form an even larger free radical. This process continues until the radical is destroyed. Students, remember it. This step is important. This process continues until the radical is destroyed. These steps are called propagation steps. The last step is the chain termination. The chain reaction terminates with the net loss of one free radical when combining with another radical. We call it combining radical. Next, we will see it in mechanism. So, it may occur by the collision of growing chain with coupling or disproportionation. So, it's an important point. There is two method or two way of the mechanism for chain termination. One is the combining radical and another is the disproportionation. However, if growing chain collide with an initiation radical, undesirable impurities are the wall of the reaction vessel, then it might also terminate. So, we will study now the mechanism. Here is the example is the polymerization of ethylene monomer to polyethylene. We studied the overall theory of this process, what's happening in each steps. Now we will discuss in case of the mechanisms. Initiation step, as we need the initiator, we will use initiator as a phenyl radical. So already told you that this benzoyl peroxide, the oxygen bond oxygen, it will homolytically break in the presence of heat or either sunlight. It will convert into the benzoyl oxy free radical, which is unstable, and further it will break bond and it carbon dioxide molecule release, and the stable one is the benzoyl radical is separate out. This benzoyl radical is used for as an initiator for initiation step. This pH free radical, phenyl radical, will attack on this monomer. This pi bond will break and free radical move on each carbon, and one free radical will combine with this pH free radical or this phenyl radical and they form a bond, and another carbon free radical is present as a free radical on the terminal position. This free radical will work or will attack on another monomer, and the process is repeat and repeat in the propagation step. So this PHCH2 single bond CH free radical, it will attack on this new monomer and activate it, and this pi bond will again break, process is repeat. This free radical move on this carbon, a free radical move on this carbon, and this free radical and this free radical will make a bond, and this free radical will present as on the terminal point will attack on a new monomer, and this process is repeat continue until the polymer having radical end. If the polymer having their radical end, the process will continue. So, in last step, in termination step, the mechanism work in two ways we have studied in theory topic. Either it may be radical combination or disproportionation. So both cases we will discuss one by one. The first one is the radical combination. In radical combination, this free radical and this free radical will combine with each other and make a bond. And this is whole a high molecular weight polymer is formed and chain is terminated. In this chain, there is no free radical is present to activate or further extend or attack on new monomer. So this is a process of the radical combination. And what about disproportionation? Student, disproportionation mean both unsaturated molecule or saturated molecule must be as a product, or we can say that the formation of saturated, either single bonded and unsaturated molecule is formed. So how it is formed? So let us see and let to understand. This is the terminal free radical chain is present. This another chain is present. Student, this if this terminal carbon free radical will attack on this hydrogen, it will grab this hydrogen. If this CH2 pick this hydrogen and this hydrogen leave its radical on the carbon chain, and it will convert into the CH3 and chain is terminated, free radical is reduced. So this is a CH3 and chain is same above like other. The change only this point, this CH2 pick the hydrogen from this terminal position, and this is a saturated molecule. Now what happened in this? This hydrogen left its free radical on the carbon, and this free radical and this free radical which is already present in make a bond as a pi bond, and this is a unsaturated molecule. Both molecule stable now. This is saturated molecule, this is unsaturated molecule. This type of the formation of product is said to be disproportionation. So termination step we have see two ways, either radical combination, chain is stopped, and either disproportionation, the chain is stopped and two different product is formed. So student, I hope you enjoy this lecture. You understand nicely. Kindly share your feedback. Thank you.